All right, what's up, everybody? It's Dr. J, and today we are talking about Lewis structures, and we have methyl chloride. So with Lewis structures, there's a couple of different ways you can do this, but the very first thing you should do is figure out what is your total valence electrons. That's that VE for y'all. All right, so what I'm doing over here is that I'm going to figure out those valence electrons by doing electron configuration. And right now I'm putting the atomic number by them. So carbon 6, hydrogen is 1, and then chlorine is 35. No, it's not, everybody. It's actually the mass number. I'm thinking about Kevin Durant. So that was actually my mistake. In fact, the actual atomic number is in fact 17. Okay, so you want to make sure that you have the correct atomic number when you're doing these electron configurations. So let me get rid of that one right there and put 17. So now I'm going to do the electron configuration for these particular elements. The reason why it's carbon, hydrogen, and chlorine is because I have a carbon, hydrogen, and chlorine in my methyl chloride overall compound, right? So if y'all remember, electron configuration is always the same thing, right? Because we're always filling in our orbitals. So it's going to be the same order every single time. That's not going to change. The only thing changing, right, is the amount of electrons we're filling in those orbitals, right? Because that's what electron configuration is, the description of orbitals. So when we're looking at carbon, we got 1s2, right? 2s2, and then 2p, not 6, but 2. There I go, y'all messing up again. So that's a 2 right there. And remember, it's 6 because we have 6 electrons. So now I'm just going to fill it in for my hydrogen. In this case, I got 1 electron, so it's just going to be 1s1. And then with my chlorine, right, I got 17 electrons, so I need to fill them in one by one until I have 17 total. So 1s2, 2s2, 2p6, that's at 10, right? 3s2, that is 12. And then in this case, I need to fill the rest of them in my 3p orbital. In that case, it's just going to be 5. Okay. So what do we realize from here, right? We realize that we can find our valence electrons. In this case, it's just the outermost shell. So my carbon has 4 because I have 4 in my 2 in my 2s2, 2 in my 2p2. Hydrogen has 1 in my 1s orbital, and chlorine has 7 valence electrons in my 3s2 and 3p5. So everybody, we just adding up all of our electrons in my outermost shell. So from there, we just count everything up. So my carbon, once again, it's going to have 4 valence electrons. My hydrogen has 1, and my chlorine has 7. So that's a total of 14. All right. So now let's draw the actual Lewis structure. I'm going to draw a little bigger, you know what I'm saying, because that was just too small. I don't know what I was thinking. But I'm going to put carbon in the middle. The reason why carbon is going to go in the middle is because the other two elements, in this case, hydrogen and chlorine, hydrogen and chlorine, right, these are terminal. Hydrogen is normally going to go terminal, so that means in the outside position. Chlorine isn't going to be in a terminal position this time because it's the most electron negative element, okay? So in this case, any electron negative atom is usually going to be in a terminal position, right? Those chlorines, those bromines, those halogens, all of those boys. So with Lewis structures, we need to make sure that we're satisfying our octet rules and our duet rules. Chlorine follows the octet rule, so that's the reason why we see 2, 4, 6, 8 electrons surrounding it. Our hydrogens follow the duet rule. That's the reason why they're satisfied as just seeing 2 electrons with those lines, right? A line represents 2 electrons. My carbon is satisfied with the octet rule at 8 electrons too.